Good morning, class. Today we're going to talk about binomial theorem, but we first will talk about Pascal triangle. Now, this topic is to help you expand a binomial that is raised to a certain power. For example, consider the special product x plus 3 quantity squared, that is a perfect squared, and another which is 3x plus y quantity squared. We know what this means. We're going to look at them a little bit closer. However, there are common mistakes I wish not to happen when you do your operations or attempt to do the algebra in this. Ladies and gentlemen, the expression x plus y quantity cube does not equal the sum of the cube. It does not. Similarly, expression a minus b quantity cube does not equal difference of cube. It does not. All right? Now, let us see what we're talking about as for distributing the exponent. Consider the expression 2x plus 7 quantity squared. We all know what that means. This is the expression 2x plus 7 times the expression 2x plus 7. We know that. You've done that enough to know. You apply the distributive property to obtain your answer. Then combine like terms and so forth. Ladies and gentlemen, you can use FOIL, or if you coil it FOIL, that is, it is the distributive property. Now, you would obtain 4x squared plus 28x plus 49 after you do all that. Consider another one. Ladies and gentlemen, if we have x plus y to the cube, we know it's the same expression times itself 3 times. At this point, ladies and gentlemen, you would apply the distributive property with the first two, and the answer you get, you apply the distributive property again, and you would obtain x cubed plus 3x squared y plus 3xy squared plus y cubed. At this point, ladies and gentlemen, we can use the distributive property practically for any binomial raised to a certain power. But this expression right here tells you negative 3y plus 7w multiply itself 6 times. You would have to apply the distributive property with the first two. Then the answer you get, you use it to the distributive property with the third one, and so on and so forth. You carry out that action. Ladies and gentlemen, I ain't got time for that. Now, so we're going to talk about the Pascal triangle that would help us get through this procedure rather fast. So, let's see what the Pascal triangle is. The Pascal triangle, ladies and gentlemen, is as follows. What it does, it provides me with the coefficients of the terms which I would get if I apply the distributive property. Now, the truly meaning of this is the fact that the Pascal triangle gives you how many ways you can arrange these things, given that each of the exponent is distinct. But for the moment, let's try to get you to just use the Pascal triangle to find the expansion of a binomial. Now, consider we have the following. Negative 3x plus y quantity cube. Of course, that would mean the same binomial multiply itself 3 times. Now, if we use the Pascal triangle, it tells us the coefficients for this particular product. We should get 1 plus 3 plus 3 plus 1. Notice there is always a plus sign, ladies and gentlemen. Always a plus sign, eh? Okay, now, to carry on from there, each of the terms is going to be behind the coefficients, which means behind every coefficient we put both of the terms. With the terms there, we want to make sure that the exponents always equal to 3. Always. So, let us see what we have. Now, look at this. The first coefficient, 1. We put the term negative 3x to the third power. That means the y, which is the other term, have 0. Then we go to the next term. Negative 3x, it should be negative 3x, excuse me here. So, negative 3x to the second power, and we have y to the first. And right here, we have negative 3x, then y to the second power. And on the third one, the negative 3x is 0 and y to the third. So, as a result, ladies and gentlemen, we end up with negative 27x cubed plus 27x squared y plus 9xy squared plus y cubed. This is what the answer is. I did less work. I did not have to multiply this by itself 3 times and apply the distributive property 3 times in order to get it. So, ladies and gentlemen, that's how you use the Pascal triangle. So, let us look a couple in class, and we will go from there, and you can complete your assignment.